Okay, in this video we are going to look at graphing quadratic functions, and specifically graphing quadratics that are in standard form, which is what we call the form we have right here at the top of the page. A, B, and C in this case are constants, and it would always be that A is not equal to 0. Because if A was 0, we wouldn't have an x squared term at all, and then it wouldn't be a quadratic. So things to know about the graph of a quadratic function: it is always going to take the shape of a parabola. That leading coefficient, a, the number in front of your x squared, is going to tell you which direction your parabola opens. If a is greater than 0, or if it is positive, then your parabola is going to be open facing up. If a is less than 0, or that would be a is negative, your parabola is going to be facing down. We also will need to find the vertex of our parabola. The vertex will always be either the maximum or the minimum. If you have an upward facing parabola, your vertex will be your minimum point. And if you have a downward facing parabola, your vertex will be your maximum point. And we use the vertex formula to find that. And here it is, h equals negative b over 2a. That gives us the x coordinate of our vertex. And then we take that value and plug it into our function. And that gives us the y coordinate of our vertex. The axis of symmetry is always going to be a vertical line, and our parabola is symmetric about that line. So a vertical line always takes the form x equals some constant, and that constant is the x coordinate from your vertex. Then we also have our intercepts. Just like graphing any function, the x-intercept is found by setting y equal to 0 and solving for x. With a parabola, we could have no x-intercepts, or there could be 1, or there could be 2. And then y-intercepts, we set x equal to 0 and solve for y. There will only ever be one y-intercept. Okay, so let's look at our first example. First of all, the coordinate of our x squared term here is just 1, so that means our a is equal to 1. And that tells us that our parabola opens up. Next up, we want to find the vertex. The vertex is 2 points, an x coordinate and a y coordinate. The x coordinate, which we usually call h, is found by calculating negative b over 2a, which for our problem here is negative, our b is negative 2, and our a is 1. So those two negatives knock each other out. We get 2 divided by 2, or 1, for our x value. To find k, we take that x value that we just calculated and plug it into our function. So we get 1 squared minus 2 times 1 minus 8, which gives us 1 minus 2 minus 8 is a negative 9. So our vertex is the point 1, negative 9. Our axis of symmetry is always a vertical line. So it's going to take the form x equals, and it will be the x coordinate of our vertex. So x equals 1 in this case. Then we'll want to look at our intercepts. Our x-intercept, put 0 in for y, or f of x. To solve this little equation we have here now with 0 plugged in, we need to use one of our quadratic solving techniques. I think most often when we're graphing, you'll probably either factor or use the quadratic formula. This one I think is a pretty easy factor, so we might as well do that. That trinomial factors into x times x, and my 8 I will split into 4 times 2. To get a negative 2, that means I would need a minus 4 and a plus 2. So we set each one of those factors equal to 0. And so we get 2 x-intercepts, one at 4, and one at negative 2. Again, those x-intercepts, those are points, so we would write those as ordered pairs. And then we'll look at our y-intercept. Y-intercept is usually going to be a pretty easy calculation because we're just plugging in 0 for all those x values. So we get 0 squared, which is 0, minus 2 times 0, which is also 0, minus 8. So that is just negative 8. So there's our y-intercept. And so I think we're ready to put all of that information on our graph. So we'll start with the vertex of 1, -9 right there. We know that our parabola is going to open upward, so that's going to be our minimum value right there. I'm also going to sketch in that axis of symmetry because sometimes that can be helpful when we're plotting points. Then next we'll put in those x-intercepts. We have one at 4 and one at -2. So right there and right there. And then we'll also put in our y-intercept. That's at 0, -8. And here's a place where we can use that symmetry property. Since this point we just plotted is 1 unit to the left of our axis of symmetry, we know there has to be a corresponding point 1 unit to the right of our axis of symmetry. And those 5 points really give us a pretty good idea of the shape of our parabola. We don't even need to plot any additional points on this one. Looks something like that. Okay, let's try another one. Okay, again, start over, same checklist, take it from the top. In this case, our a is equal to 2. Again, a positive number, so this tells us that our parabola is going to open up. Our vertex, we need both coordinates. The h coordinate is -b over 2a. So those negatives knock each other out, and we get 16 over 4, which is +4. To find the other coordinate of our vertex, we plug 4 into our function. 2 times 4 squared minus 16 times 4 plus 33. I just recommend grabbing your calculator, plugging that all in, and you should get 1 for the value. So our vertex is the point 4, 1. And then we can look at our intercepts. Our x-intercept, that's where we put 0 in place of y, or f of x if we're using function notation. Again, factoring is nice if it works. This one's not going to factor, so we'll need to use that quadratic formula to solve. Remember from several units ago, x equals -b plus or minus the square root of b squared minus 4 times a times c. Oops, 33, that should have been 33. All divided by 2 times a. Sorry, 2 times 2. That's what a is. Okay, so we start simplifying. Negative and negative, those knock each other out. We get a +16 plus or minus 16 squared is 256. And 4 times 2 times 33, that ends up being a -264. Divided by 2 times 2, which is 4. And when we subtract this, 256 minus 264 under our radical, we end up with a -8, which should be a red light. We cannot take the square root of a negative number. So what that means is that we actually don't have any x-intercepts. So this parabola is not going to cross the x-axis at all. And when we start graphing it, you'll see that that makes sense in this case. Our y-intercept, 0 goes in for x. 2 times 0 squared is 0. Minus 16 times 0 is also 0. Plus 33. So our y-intercept is going to be at 33. That point's going to be off our graph, so that one's not going to be so helpful. But let's go ahead and draw what we do have. So we have a vertex of 4, 1 right here. We have no x-intercepts. We have that our parabola is opening upward. I am going to sketch in that axis of symmetry right here. Our y-intercept is somewhere way off the page up there. So now we're going to have to plot some more points. Last time we had enough information that we didn't have to do this, but this time that vertex is not enough. We're going to need a few more points. So if our vertex is at 4, maybe we want to plug in x equals 3 and see what's happening. So we would get 2 times 3 squared minus 16 times 3 plus 33. And I just plugged that all in on the calculator, and that turns out to be 3. So the point 3, 3 is going to be on our parabola. And again, we'll use that symmetry property to give us another point. We have to have the mirrored point on the other side of the axis. And then maybe one more value, we plug in x equals 2. 2 times 2 squared minus 16 times 2 plus 33. And that turns out to be 9. So we'll plot that point right about here. And again, using that property of symmetry, that means we must have another point 2 units to the right of the axis. And there we go. That gives us enough information now to sketch in our parabola. Opens upward, no x-intercepts, and that y-intercept would be somewhere way up there at 33. Okay, here's another example. Go through the same steps that we did before. This time our excuse me, our a value is -1. So this is going to be our first parabola that opens downward, faces down. Our vertex h equals -b over 2 times a. So we get a positive 4 over a -2, which is -2. And then to find the y-coordinate of our vertex, I'll plug -2 into our function. So we get -2 squared minus 4 times -2. Be careful with all those negative signs. That can sometimes mess people up, because here the -2 gets squared, so it becomes a positive 4, but there's still that leading negative sign out front, so it goes back to -4 plus 8 minus 6, which is -2. So we put these two together, and our vertex is at -2, -2. And again, this is not a bad idea to stop and think here. If our vertex is at -2, -2, so that will be right here. And I know this opens downward, so what does that tell me about my x-intercepts? Well, it tells me that I'm not going to have any. I'm going to go ahead and do the calculation here for you just to show you what that looks like. To find the x-intercepts, we put 0 in for y, or f of x. Again, this one's not factorable, so we'll use the quadratic formula. -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So when we simplify underneath that radical, we get 16 minus 24, and we're just going to stop right there because I can tell that's a negative number, so that means no x-intercepts. To find our y-intercepts, those are always the easier calculation. We just put 0 in for x, so we get -0 squared, which is 0, and -4 times 0, which is 0, and -6. So our y-intercept is at 0, -6. So we have our vertex ready. I'll sketch in that axis of symmetry, which will be right down the same x value as our vertex. We have a y-intercept at 0, -6. 2, 4, 6, I think about right there. And using that symmetry property, that means we must have another point 2 units to the left of the axis of symmetry. And those 3 points give us a pretty good idea, but just to be safe, let's plug in one more value for x. We have the vertex at -2, we have the intercept at 0, so maybe we plug in x equals -1. So that leaves us with -1 plus 4 minus 6, which is -3. So -1, -3 would be right here, and using the symmetry property, another point over there, and then we can sketch in our parabola. Okay, just one more example in this video. I want to make sure you guys really have this, and this one has some fractional intercepts. So we'll take a look at it. Okay, again, same checklist. Start with A. A is -1, so that tells us that this is going to face down. And then we want our vertex. H equals -b over 2 times A. So -4 for our x-coordinate. Plug in -4 into our quadratic. Again, I just kind of plugged that all into my calculator and I got 3. So our vertex is at -4, 3. And it opens down, so let's see if that tells us anything about our intercepts. -4, +3, opens downward. So yes, we should get a couple of x-intercepts. We should get 2 of them if our parabola is going to open downward. So let's work on that calculation next. 0 equals -x² minus 8x minus 13. Can't be factored, so again we use the quadratic formula. X equals -b plus or minus the square root of b² minus 4 times a times c. Lots of negative signs in there, watch your signs. All divided by 2 times a. So we do some simplifying. We get 8 plus or minus the square root of 64 minus 52, all divided by -2. 64 minus 52 is 12. The square root of 12 can be simplified. It's 2 times the square root of 3. And then we can do a little canceling or division here. 8 divided by -2 is -4. And then 2 times the square root of 3 divided by -2 is just the square root of 3. So those are our 2 x-intercepts. Since we are actually graphing, I recommend plugging those into your calculator and getting a decimal approximation, because this is not very useful when it comes to graphing. Turns out the 2 values you will get rounded to the nearest tenth is -5.7 and -2.3. And then our y-intercepts, intercept, just 1. Again, 0 minus 0 minus 13. It's just that constant at the end. So our y-intercept is 0, -13. So let's sketch in what we know. I'll put in that axis of symmetry again. I didn't write it this time, but it would be x equals -4. So it'd be right there through our vertex. Our intercepts, our x-intercepts are decimals, but just do your best to kind of approximate 2.3 and try to go a little less than 2.5. And 5.7 will be about there. And since those are decimals especially, let's get at least one more value for x. Maybe we want to try x is -1. So to get our y value, we calculate f of -1 times -1 minus 13. And that turns out to be -6. So -1, 1, 2, 3, 4, 5, 6. Our next point's about there. And using that property of symmetry, this is 3 units to the right of the axis. So I must also have a point 3 units to the left of the axis of symmetry. And there we go. From there we can sketch in our parabola. And that's it.